Welcome to another video from ExplainingComputers.com. Over the years on this channel, I've reviewed several different Raspberry Pis and other single board computers. Recently, however, I've become aware there are now some mini Windows PCs in roughly the same price bracket. And indeed, if we take a look at Amazon, we find several mini Windows PCs selling for $100 or less. And so in this video, we're going to have a look at one of them, specifically this, the Bmax Mini PC B1 Plus. So let's go and take a closer look. Right, here we have our Bmax Mini PC, which is currently selling on Amazon.com for $99.99 and on Amazon Co UK for £99.99. So let's open this up. Very simple thing to unbox, bit of packaging, and under here there is a message on the bag which basically says we should not connect to the internet on the first boot. I'll try and remember that. Over here I imagine how this is, there we are, bits and pieces. This is the power supply, well not bits and pieces, we kind of need a power supply. And we've also got down here an HDMI lead. That's nice, have that included. Didn't have to have that included, they have. This is instructions, I'm presuming that's a bracket so we could hang this on the back of the monitor, something like that. And this of course is the PC itself. Get this thing out. Oh look, there's something I'm battling, there always is, isn't there? And here we are, here is the mini PC. Little thing, isn't it? Let's just put that box down there. Dear me, making lots of noise and mess. Let's just compare this for a second to, if I can find it, here's a Raspberry Pi, getting caught in the boxes off camera there. It is bigger than a Raspberry Pi, obviously not massively bigger. I've also got down here somewhere, this is a Rock 5B, so it is bigger than these single board computers, but not massively bigger than these single board computers. This is, I think, 120 millimeters square and about 30 millimeters deep. And inside the case, which I think I've got backwards actually, I think the front is actually that edge there. Inside this case, we have a dual-core Celeron N3350 64-bit CPU with a 1.1 GHz base frequency bursting to 2.4 GHz. And this 2016 chip also has Intel HD Graphics 500 and is passively cooled. So this is a silent computer. In terms of memory, we've got 6 GB of DDR4 RAM, which is very good on a mini PC at this price point, where it seems 4 GB is more common. And as a boot drive, there's also 64 GB of onboard eMMC flash storage, which comes with Windows 10 pre-installed. I suspect that having Windows 10 rather than Windows 11 on this box may be part of the reason for the price of this and similar hardware, but even so, it'll be interesting to see how Windows performs on this computer, and of course I also intend to try a Linux distro. In terms of connectivity, on the back of the machine we find a 3.5mm audio jack, as well as a gigabit Ethernet port, although this PC also has onboard Wi-Fi as well as Bluetooth 4.2. Next along we then get a full-size HDMI port that supports up to a 4K display, as well as 2 USB 2 ports, a 12-volt barrel jack for power, and a power button. Rotating to the left edge, we find 2 Type A USB 3 ports, as well as a microSD card slot. And then turning 180 to the right edge, we discover a VGA socket. And in case you're wondering, this little machine is capable of driving 2 displays. Finally, if we turn the Bmax over, underneath we find this slot secured with a screw. Let's take a look inside. There we go, and in here we can fit an M.2 SATA SSD for extra storage. I don't know if this is bootable, but we're certainly going to find out. And so there we are, the Bmax Mini PC B1 Plus. And I'm sure if you're like me, you'd like to take a quick look inside the case. And so let's use the magic of filmmaking to flick the board over and remove the base. And as you can see inside, it looks pretty neat. this is clearly a very large heatsink on top of the CPU and everything else around the edge. Nothing very exciting in here, but it does look nice and neat. So let's now put it back together and check out its performance. Right, I've now plugged in a mouse, keyboard and monitor as well as the power supply, but not an Ethernet lead. So let's press the power button. Here we go, and this is the first boot of the system, and it says Bmax, so things must be working. Anyway, let's now speed on through. And here we are, it wants us to select a language. I'll go with English United States because that seems to be the only English option. I'll change my region to United Kingdom and my keyboard layout to United Kingdom. Skip a second layout. And I have to accept the Microsoft license agreement. And now it wants a name for a user. I'll just put a EC in there. And now enter a password and confirm. Oh, I need to do the Microsoft security questions, so I'll quickly go through these. And I'll also quickly go through the standard Microsoft questions. And here we are, we've arrived in Windows. That was less than 12 minutes in the real world, in real time. That's not bad. We'll say maybe later to Microsoft Edge down there. And I presume we've got a standard Windows menu. Is it going to come up? Yes, things seem to be working okay. So what I'm now going to do is to plug in an Ethernet lead. I'll let Windows do all the updates it no doubt wants to do, and I'll come back to you for a look around after that. Greetings! Windows is now fully updated, which took about 3 hours to process. And if we go to this PC and right-click and look at Properties, we can see that on this PC, there it is on our Celeron with its 6 GB of memory, we can see we're running Windows 10 Pro, which was installed in 2022. So this isn't a computer that's been sitting on the shelf for a long time. It's a relatively recent install. And I was surprised to find we've got Windows 10 Pro. And I was also surprised that if we go to Windows Update, if I just go down here and find it down there, there it is. We find in Windows Update that automatic updates have been turned off by our organization in its update policies. And there's no simple mechanism for turning automatic updates back on again. So I had to manually run the update process, clicking on checking for updates. And to be honest, I don't mind doing that. Having automatic updates turned off is something I personally like. Although many users may not realize that automatic updates have been turned off and miss important security patches. And what all this clearly shows is what we have on this machine is a volume licensed version of Windows 10 Pro, which is unusual on a consumer product. Although there appear to be no problems, if we look down in activation, it tells us that Windows is activated with a digital license. Now, as you may recall, Windows is installed on 64 GB of eMMC flash storage. And before I updated, we had a 47.6 GB C drive with 29.5 GB free. And after updating, if I open up this PC, we can see we've got 19.4 GB free on our 47.6 GB C drive, although I'm sure if we run disk cleanup, several gigabytes of space will be released. Also, if we right-click this PC up here and go to Manage, and then to Disk Management when it comes up, it'll get there in a second. There we are. Good little computer. Here is a disk management. We can see here that we've got on our eMMC flash storage, not just Windows, but a Windows recovery partition. 9.77 GB for the Windows recovery partition. And it's good to have that because it means if Windows gets corrupted, you can press F9 on boot to reinstall Windows. But it does take quite a high percentage of the eMMC flash storage. So there is a certain argument to get rid of this partition and reallocate the space. In terms of software, as you can see, Google Chrome is pre-installed along with all the usual Microsoft stuff we find down in the menu. The updates added to this machine, Video Editor and PC Health Check, which reports that we cannot upgrade this computer to Windows 11. It also added in the Intel Graphics Command Center for our onboard graphics, and other than that we've just got standard Windows stuff here, a lot of garbage from Microsoft we can get rid of, but it's the sort of thing you'd expect on an empty computer. And if you're wondering what Office is here, this is a link to the free Microsoft Office web apps, which is good to see, but I want to make it clear there's no pre-installed Office package on this computer. We wouldn't expect it at the price. So let's run up Google Chrome, always good to do that, and comes up pretty quickly. It's got a decent browsing experience. And if we go across to bookmarks here, got a couple of things bookmarked. First of all, let's look at GPU internals for Chrome, where you can see that hardware acceleration is enabled pretty much for most things. We do have GPU hardware support, and I'm sure, having shown you that, you want to know what happens if we try and do some YouTube playback. So let's set up my usual YouTube playback 1080p test. Here we go, and this works pretty well. There are some drop frames, as you can see. It's not absolutely perfect, but it's a perfectly acceptable level of playback in 1080p here on the Bmax Mini PC. Certainly better playback than we've seen on many ARM-based SBCs that often cost more than the Bmax does. So I'm quite impressed with this very usable streaming media playback. So there we are. So far things are quite impressive on this $100 PC. So what I'm now going to do, I'm going to run disk cleanup, and I'm going to install some useful open source and other software so we can run some further tests. Well, I've now tidied things up, got rid of surplus Windows software, and I've also run disk cleanup. So if we go to this PC, you'll see our C drive is now about half full. It's got 23.6 gigabytes free. And this is with some additional software installed, specifically LibreOffice Writer, Crystal Diskmark, Kdenlive and GIMP. I've also got some more drives connected. I plugged in for testing a microSD card, and I've also fitted an integral SATA M.2 SSD, and I've even experimented hanging the Bmax on the back of a monitor using the provided bracket, which works very well. Oh, and we're now also running via a power meter, where we can see that the idle power use is hovering between 3 and 4 watts. So back on my desktop, let's run up LibreOffice Writer. Let's see how responsive a common application is on this system, and that came up nice and quickly, didn't it? Let's just do our standard word processor test, make it nice and big, say a big hello to everybody out there in video land. There we are. You can see LibreOffice Writer is very responsive on this system. Do we want to save that? No, we don't. Let's also run up GIMP, the GNU image manipulation program, photo editor. This comes up pretty well. It comes up the sort of speed it comes up actually on a Raspberry Pi. It's got a bit of an SBC feel, the responsiveness of this system. Let's just do a new document. We'll do new like that down there, and OK. And I've got a very exciting brush selected. Oh, it's like sort of fireworks and things. It's working very well. GIMP is certainly usable on this system. But again, having proved that will come out of a system, no, we do not want to keep our changes. We'll discard those. And I think we'll now run up Crystal Diskmark to test the speed of drives on this system. And we'll start with the C drive, the eMMC flash storage on the board. Let's run all the tests for that. And there we are, we have our results. Read of about 300 megabytes a second and very slow write speed. I almost don't believe this result. Let's put this up to doing some more samples and run this test again. And there we are, it was worth being skeptical of the initial results. Although still here we've got internal eMMC, which has got a very low write speed. Anyway, that's what we've got. Let's now test out the M.2 SATA SSD. And there we are, a better result, although nowhere near SATA 3 speeds. It suggests maybe this is a SATA 2 interface on this computer, or that there's some more fundamental limit on the storage interface on this system, because it's suspicious that's a similar result we got in terms of a speed to the eMMC flash module. Anyway, let's also finally test the speed of a microSD card on this system. And for this, I'm going back to one sampler. This could take forever to run. And there we are, A truly appalling result for the speed of a microSD card on this system. We're using a SanDisk Extreme Pro card that's capable of towards 100 megabytes a second, so these are poor results. It suggests the microSD interface in this system is connected via a couple of bits of string and a very old piece of cheese. And in fact, because these results are so low, and we had low results also for our D drive and our C drive earlier, I think I'll actually plug in a USB 3 external SSD. There we go. And I think I have to come out of Crystal Disk Mark and go back in again to see that drive. It's down there, so yes, we can go back into Crystal Disk Mark and hopefully test it. This will be a speed test effectively of the USB 3 ports on this computer. And there we are. We've proved the fastest way to increase storage on this machine is plugging in an external USB 3 drive. Anyway, let's now move on to run up the Kdenlive video editor because I want to run a render test. Here we go. And if I just bring in my test edit like that, this is a test edit I've used on many different single board computers in the past. It uses proxy clips to play 1080p footage on low power hardware. And we'll just see how it plays in general, which is okay. It's playing those ducks all right. Let's let it play the transition for us, which is, that's not bad on hardware of this type. It shows you could certainly do a little video editing on the Bmax mini PC. And let's now also do my proper test, which is go to project and render. This gives us a comparative result. We'll go across to scripts. I've got a script all set up to render out our sequence. So I'll start the script. And as that starts off, I'll let you know that on a Raspberry Pi 4 8GB model, this took 2 minutes and 19 seconds. On a Latte Panda 3 Delta, it took 17 seconds. And on an Orange Pi 5, it took 52 seconds. So let's speed on through so we can get the Bmax B1 Plus result. And there we are, a final result of 1 minute 45 seconds, faster than a Raspberry Pi, but slower than other boards I've tested in the past. Anyway, this is rather a stretch for a board like this, but I wanted to run the test. And talking of tests, it'll be a stretch. The final thing I want to run is Passmark, which I've got down here, Passmark Performance Test. We'll start that up and let it settle. There we are. I think it's now gathered its data. It tells us the CPU is currently running at about 55, 56 degrees. And we'll start off all the Passmark tests. Rather a terrible thing to do to a small computer like this, but we'll do it anyway, see how it reacts. And there we are, Passmark has started. And of course, we will speed on through. And whilst we do that, we'll look across to the meter where the maximum power consumption climbs up into double digits, with the maximum value I've been able to measure being 16 watts, although sustained energy use at load is more like 9 or 10 watts. Back over in Passmark, the 3D benchmarks are now executing. We can see our floating jellyfish in space. And whilst these benchmarks do work, it's hardly surprising they're a little sluggish on this hardware. And there we are. We have an overall Passmark score of 656. It's not a spectacular result, but I don't think it's too bad for a $100 PC. Greetings! For our final test, I've installed Linux Mint on the M.2 SATA drive, and I did this by booting up the Bmax and pressing the escape key to enter the BIOS. I then tabbed across to chipset and disabled the onboard eMMC flash storage, and then I went across to save and exit, where I selected to boot from a USB drive with Linux Mint on it. And what this process did was to allow me to install Linux Mint on the M.2 SSD without disturbing Windows on the internal eMMC. And in particular, I didn't end up with a grub boot menu on the Windows drive. And when Linux was installed, I turned the internal eMMC storage back on again and changed the boot order back to Windows first. So the Bmax now boots by default to Windows, or I can press F11 to select Linux Mint via the BIOS boot menu, which these days is by far the safest way to dual boot. Anyway, here in Linux Mint, everything is working fine. I've had no driver issues, and indeed Linux Mint actually prompted to install an appropriate Wi-Fi driver. So to celebrate, here we're currently connected to my network using the onboard Wi-Fi. But other than this, I have nothing to report. If we look in system information, you'll see things are as we would expect. There's our hardware, everything's picked up, is working fine. And system performance here is very, very similar to Windows. Programs launch and things just as they did in Windows. Nothing is very different. I'm not going to run any significant tests here because everything works exactly the same. It's just running in Linux rather than running in Windows. There we are. LibreOffice Writer comes up exactly the same. Do I want to know things? No. Surprisingly, I never do. Oh, I will though just run up the Chromium browser, and I'll do this to show you if we go to the GPU internals test here in Chromium, that GPU hardware acceleration kicks in just fine, just as it did in Windows, and just as it doesn't in Linux on most ARM single board computers. And so there we are. If you want to run a Linux distro on this mini PC, you should have no problems. The Bmax mini PC B1 Plus is an impressive piece of kit that certainly got me thinking. For $100 or £100 or a bit less if you're lucky, we get a PC with a Windows 10 Pro license that's got decent streaming media playback, and it runs an Office package and a web browser perfectly well for all the basic computing activities. You could even do a bit of photo editing, things like that, as we've seen. The only thing you don't get with a mini PC like this compared to the SBCs I so often review on this channel is GPIO, general purpose input-output connectivity. So you couldn't take a board like this out of the box to use it to, for example, control a robot. However, it is possible to cheaply add GPIO to any PC, including this one, and that's something I'm going to be covering in a future Explaining Computers episode. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.